The default storage mode for a partition is called MOLAP, which stands for multidimensional OLAP. With MOLAP, all data is stored on the analysis server. When we process the cube, data is read from the relational source according to the rules defined in the UDM, which stands for Unified Dimensional Model. The UDM is where all the dimension and cube definitions and other settings in the cube reside on the server. The UDM also contains the aggregation design, which the server then processes to store aggregations on the server. When a client application sends an MDX query to the server responds from the data or aggregations in the cube. MOLAP storage is an efficient way to store data in a partition. It's highly compressed and indexed, and does not require as much space to store data as the source data itself. Of course, we need to maintain the source data so that we can reprocess the entire cube whenever necessary, even if our standard practice is to process only the current partition. Sometimes changes are necessary that require a full reprocess of the database. Another storage mode is called HOLAP, which stands for Hybrid OLAP. With HOLAP, only the aggregation data is stored on the analysis server. When we process the cube, data is read from the relational source in order to calculate the aggregations, which are stored on the analysis server. When a client application sends an MDX query to the server responds with the result derived from aggregations if possible, which is the fastest type of query. But if no aggregations exist to answer the query, then the UDM is used to translate the MDX query into a SQL query, and the analysis server sends the SQL request to the relational source. When that happens, the result is returned, but query performance is slower than it would be in MOLAP. There's nothing that the user sees to indicate that the storage is different from MOLAP, although the user will likely notice slower query performance. This storage is most often used when a large relational warehouse is in place for other reasons, and the majority of queries can be answered by aggregations. If the difference in performance between MOLAP and HOLAP is minimal, HOLAP might be a preferable option rather than adding the overhead of additional processing to create a MOLAP store of the detailed data when the number of queries requiring the detailed data is small. The third storage mode is called ROLAP, which stands for Relational OLAP. With ROLAP, only the UDM is stored on the analysis server. When we process the cube, no data is read from the relational source, but instead, Analysis Services checks the consistency of partition metadata. If we design aggregations for a ROLAP partition, Analysis Services creates indexed views, so there's no additional copy of aggregation data like we have in MOLAP or HOLAP mode. When a client application sends an MDX query to the server translates the request into SQL and returns the results. Query performance is slower than it would be if the data were stored in MOLAP mode. However, the benefit of this approach is access to fresh data for real-time analysis. In MOLAP mode, the data is only as current as the last time the partition was processed. Speaking of ROLAP, we can also store dimension data in ROLAP storage mode. When we do this, the dimension data does not get copied to the analysis server during processing. Instead, dimension data is retrieved only in response to a query. The analysis server maintains a cache of dimension data that updates with each request. That cache is the first place that Analysis Services looks before it issues the SQL query to the relational source to get the dimension data. We use this option only for very large dimensions with hundreds of millions of members, so it's a rarely used feature of Analysis Services.